Hello students, today we will learn a very interesting context in the field of physics, that is Buckingham Pi theorem. Buckingham Pi theorem is used to derive non-dimensional numbers, and non-dimensional numbers in turn used to derive empirical relations. Now what are non-dimensional numbers and what are empirical relations? That you will be able to understand at the end of this lecture. First of all, refresh your mind with basic knowledge of dimensions and dimensional analysis. All those things, those attributes, dimensions, dimension analysis, fundamental dimensions and derived dimensions and all. So for that I am going to speak first. See, what is a physical entity? Physical entity is that thing which is having its definition, which is having its existence in nature, which is having the word being with it. For example, anything which is having some definition which we know that it exists is a physical entity. For example, feeling is a physical entity, philosophy is a physical entity because we know what philosophy is, length is a physical entity, mass is a physical entity, order is a physical entity. So all these things are physical entities. Now what are physical quantities? Physical quantities are those physical entities which can be measured. For example, odor can be a physical entity but cannot be a quantity because odor is there. We know that odor exists. So therefore it is a physical entity. But since we cannot measure how much odor it is, so just we can feel it, therefore it cannot be a physical quantity. So physical quantities are those type of physical entities which can be measured. So length, mass, time, velocity and many more examples are there which can be measured. Therefore physical quantities are those which can be measured like this. Now physical quantities themselves are made up of some fundamental physical quantities and derived physical quantities. What are fundamental physical quantities? Fundamental physical quantities themselves are unique. They are not composed of any sub fundamental quantities. For example, English literature are composed of 26 letters of English. All the words which are comprising this English literature and all the collection of the words of English are ultimately composed of 26 letters of English. So similarly, the fundamental dimensions are like ABC of all the physical quantities. So fundamental quantities are those which are fundamental among themselves and derived quantities are those which are composed of fundamental quantities. The fundamental quantities are also called as fundamental dimensions and derived quantities are also called as derived dimensions. So another name of fundamental quantities are fundamental dimensions and another name of derived quantities are derived dimensions. Now remember one thing, that most basic fundamental dimensions considered are mass, length and time. However, in SI system of units, there are 7 fundamental quantities. Those are mass, length, time, luminous intensity, electric current, temperature and amount of substance. But out of these 7 quantities, the mass, length and time are even most basic form of fundamental quantities like this. Now what are dimensionless quantities? Dimensionless quantities are those type of quantities which are not having any mathematical dimensions, however they can be measured. For example, angle. See, angle is a dimensionless quantity because the definition of angle is defined as the length of arc upon radius of circle. Suppose we are considering some circle and over that circle we are considering some arc. So in case we are joining the either ends of the arc over the center of the circle, then it makes some angle. So that angle is defined as the length of the arc upon the radius of the circle. So since length of arc itself is length and radius is also length, so therefore length by length cancels out each other. Therefore angle is not having any as such dimension with it. Still angle can be measured, so therefore it is a physical quantity called as dimensionless quantity. So not only angle, there are many more types of dimensionless quantities. For example, solid angle, Reynolds numbers are also some sorts of dimensionless quantities. So here are some dimensional formulas for some physical quantities. For example, kinetic energy is defined as half mv square. So in case we put the dimensions of this m, that is only m, and velocity is defined as distance upon time, so therefore it can be written as L upon t to the power 2. So ultimately we get that kinetic energy is having dimensional formula ml square t to the power minus 2. Similarly, force is having its dimensional formula mlt to the power minus 2. Similarly, the viscosity is having its dimensional formula after keeping the dimensions of the corresponding variables over the right hand side expression. We get ml to the power minus 1 and t to the power minus 1. So these are some dimensional formulas. Now remember one thing, that all physical formulas of same physical quantity will essentially have same dimensional formula over LHS and RHS. This principle is called as dimensional homogeneity. What does it mean? That for same physical quantity, whatever the type, whatever the kind of physical quantity is, the dimensional formula remains the same. For example, energy is having dimensional formula ml square t to the minus 2. So now in case we take kinetic energy, so kinetic energy will also have the same dimensional formula, that is equals to ml square t to the minus 2. Similarly, potential energy, gravitational potential is given by mgh. So in case we put the dimensions over the right hand side expression, the corresponding dimensions over the right hand side expression, again we will get ml square t to the minus 2. Similarly, spring potential energy is given by half kx square. So in case we put the dimensions of k and x over this right hand side expression, again we will get ml square t to the minus 2. So we conclude that for same type of physical quantity, whatever the type of physical quantity is, whatever the kind of physical quantity is, the dimensional formula remains the same. This thing is called as dimensional homogeneity. Now how we can apply this dimensional homogeneity principle? There are two chief applications of dimensional homogeneity principle. Those are, first, to check the correctness of physical formula, because we know that physical formula can only be correct in case the left hand side dimension equalizes the right hand side dimensions, and to derive new physical formula by the given variables. Means in case we want to find out some entirely new formula, and in case we are given with some variables by the help of which we have to form the formula, then we can use the dimensional homogeneity principle to form the formula. Now let's take an example to derive a new formula in which there is a kite whose area is A and air is falling over the kite, and we are interested to find out that how much force will be applied over the kite in case the velocity of air falling over it is v and density of falling air is rho, and A is the area of the kite. Means we are supposing this thing, that force applied over the kite only depends upon the velocity of air, density of air and area of the kite. So you can see stepwise method to derive the formula. First of all, we have to write it like this: F equals to K. K is the dimensionless constant, rho to the power A, V to the V and A to the C. Now in place of rho, V and A, in case we put the corresponding dimensions, we get this over right hand side, ml to the power minus 3 raised to the power A, L to the T to the power minus 1 to the power B and L square to the power C. So ultimately we can the step 3 we can see that for same basis we can algebraically add the indices, the powers can be added for same basis. So ultimately we get m to the power A, L to the power minus 3a plus b plus 2c and t to the power minus b. Now over the left hand side it is the dimension of force, that is mlt to the minus 2. So by comparing the indices both the sides, we get three equations. Those are a equals to 1, minus 3a plus b plus 2c equals to 1 and minus b equals to minus 2. So since there are three equations and three unknown variables, so we can solve it out. So ultimately we get the result a equals to 1, b equals to 2 and c equals to 1. So our formula becomes f equals to k rho v square a. Now this is our formula which we have derived by dimensional homogeneity principle. And what is dimensional homogeneity? Once again, that dimensional homogeneity says that left hand side dimensions must be equals to the right hand side dimensions of the formula. So now how to find out the value of k? That can be found by the help of the experiment, means fly the kite. Now for particular value of rho va, means measure the value of density, velocity of air and area of kite and force applied over the kite. Practically this the force applied over the cord. Now f by rho v square a, whatever number we get, that is the value of k. So by this way we can also find the value of k. So all in all, how we got the formula? Simply by the dimensional homogeneity principle. Since force depends upon velocity, density and area of the kite. Velocity corresponds to velocity of air, density corresponds to density of air, and area corresponds to area of kite. So say in case force depends upon v, rho and a, in that case by applying dimensional homogeneity principle, ultimately we got the formula F equals to k rho v square a. Now suppose the force applied over the kite depends upon one more variable, that is g. Means v, rho, a are there, but one more variable is added, that is d, that is acceleration due to gravity. Now in such case, suppose we again proceed in the same manner, that is applying the dimensional homogeneity principle, F equals to k rho to the a, b to the b, e to the c and g to the d. Ultimately we get three equations. Those are a equals to 1, minus 3a plus b plus 2c plus d equals to 1, and minus d equals to minus 2. Now what is the problem over here? The problem you could have understood, that is we are having three equations, three simultaneous equations, but the number of unknown variables are 4. So these simultaneous equations cannot be solved, because the rule of solving the simultaneous equation is that number of unknown variables must be equals to the number of the equations formed. So in case one more variable is added which is having its effect on the force applied over the kite, then by the general way of deriving the formula by dimensional homogeneity principle fails. We can see it fails because the number of unknown variables exceeds the number of equations formed. Now how to solve this problem? First of all, let's talk about what is an empirical relation. Empirical relation is that type of relation which comes out after doing the experiment, which we cannot derive the empirical relations. These empirical relations are found by doing the experiment and then collecting the experimental data. For example, kinetic energy is given by half mv square. So this half mv square is actually a derived formula. This half mv square is derived by some basic fundamental principles. So kinetic energy is given by half mv square, it is derived formula. Similarly, gravitational potential energy is given by formula mgh, means potential energy is given by mgh. So mg corresponds to force and h corresponds to displacement. So force into displacement is work, and we know that work and energy are analogous to each other. So therefore this potential energy formula, that is gravitational potential energy formula, is a derived formula. But what is an empirical relation or empirical formula? Suppose that there is a culture of bacteria, means there is some container in which some biological matter is present, and there is a culture of bacteria, means the number of bacteria are growing with respect to time. Now suppose we want to find out the formula between the number of bacteria with respect to the number of hours passed for that particular material. Now suppose we are having the data that in a particular numbers of hours how many bacteria are there in that particular biological material. For example, in 1 hour suppose it can be 10 millions, in next hour it can be 12 millions, like this. So in case we are having the data, suppose we plot that data in xy coordinate system, in which y we are taking as number of bacteria and x we are taking as number of hours passed. So in case we plot the points and then we join all those points, we will get a curve. Now we know this thing that for every curve drawn in xy coordinate system, for every curve there must be some mathematical relation exists, and for every mathematical relation there is some curve. So for this curve also, however this curve is a rough drawing because the points are discrete, so joining all those points will give roughly a type of curve. So this curve must have some mathematical relation with it. So in case by mathematical simulation or mathematical method, mathematical operation, we are able to find that what is the relation between these two variables, that is the number of bacteria and the number of hours passed. Suppose that relation comes out to be n equals to 4.41 plus e to the power 0.01 h. Here n corresponds to number of bacteria in millions and h corresponds to number of hours passed. Then this relation is called as empirical relation because we have not derived these equations. Actually, we are having some experimental data that is plotted in xy coordinate system, and then by joining all those points we got a curve, and for that particular curve we found the mathematical relation by mathematical techniques. So this type of operation to find out the mathematical relation by experimental approach is called as empirical relation. Now coming back to our kite example, we know that the total number of variables involved which affects the force developed over the kite are F, rho, G, A and V. Now let's derive the empirical formula. Now we were just saying that formula has to be derived between two dimensions x and y. So since number of variables are 5, so we have to convert it in two dimensions. So how to convert it? Now randomly suppose I pick up three variables. Suppose I pick up F, rho and A and multiply it to make M like this, and the remaining variables are now V and G. Now multiply V and G and make it N. So now the 5 variables are reduced to only 2 variables, M and N. M contains F, rho and A and N contains V and G. Now suppose I do the actual experiment in which actually I fly the kite and then I collect the data. Then for particular set of datas there will be a particular M and particular N, because M corresponds to F, rho and A, F into rho into A, and N corresponds to V into G. So for particular M there is a particular N. So by plotting M's for particular N's, I will get a curve or not. In this Mn coordinate system I will get a curve. By connecting all those points I will get a curve. So for that particular curve there will be a particular relation. So by mathematical analysis I can find out that what mathematical relation perfectly fits with that particular curve. Suppose it comes out to be M equals to N cube plus 2.34 N plus 2.1. So this is our empirical formula between M and N. So in case I want to find out force anytime, then simply I have to divide the right hand side expression of this formula with rho and A, because M corresponds to F into rho into A. So in case both the sides I divide by the rho into A, then I will get F equals to the right hand side expression upon rho into A. So like this I can find out the force applied over the kite. But the problem in this formula is that however this formula is correct in terms of magnitude, but in case we check the dimensions both the sides, then we can see that both the sides dimensions are not matching. This formula is correct in terms of magnitude, but dimensionally it is incorrect because it is dimensionally inhomogeneous formula, because for any physical formula the right hand side dimensions must be equals to left hand side dimensions. So by this way this formula is incorrect. Now how to choose the variables and arrange the variables so that this problem doesn't arise? Now again, first what we have to do is total number of variables are F, rho, G, A and V. We know this thing. Now do one thing, that we have to make a core group. Now what is core group? We have to pick up some variables from these total number of variables, and collection of those picked up variables is called as core group. Now how to pick up the variables? First of all, leave that variable for which the exercise is to be done. For example, the exercise in this problem, this kite problem, we are doing for force, that is F, so therefore we cannot choose F. Now secondly, from rho, G, A and V, we have to choose pick up some variables. Now how many variables we have to pick up? Find out what are the fundamental types of dimensions or variables, total fundamental types of variables which are involved in these variables. See, we can see that all these variables F, rho, G, A and V are composed of 3 types of fundamental variables, M, L and T. So therefore we have to choose 3 variables in our core group. Okay, so once more, that the number of elements in core groups is exactly the same to the types of fundamental dimensions involved in the total number of variables. So since in these total variables the total types of variables are only m, l and t, so therefore we have to choose only 3 variables in our core group. Now the third principle to make the core group is that the core group must not miss any fundamental dimension involved. For example, see, we cannot choose f because for f we are doing the exercise, so out of rho, g, a and v we have to choose 3 variables because total number of types of fundamental dimensions involved are 3, so therefore we have to choose 3 variables. Now f, rho, g and a, we can choose g, a and v, we can choose rho, g and a, or we can choose rho, g and v. So 3 types of choosing can be done. But in case we choose v, g and a, then the problem is that v is having dimensions l t to the minus 1, g is having dimension l to t to the minus 2 and a is having dimension l to the power 2. So therefore we cannot choose because m is not there. We cannot miss any fundamental dimensions. Okay, so since the total number of fundamental dimensions involved are m, l and t, so therefore whatever the variables we choose for making the core group, that core group must contain that type of variables which are having all types of fundamental dimensions involved. So we cannot choose v, g and a. So either we can choose rho g a or rho g v, whatever we can choose. So we are having the 2 options, that rho g a or rho g v we can choose. So let's choose rho g v. Now do this thing, this exercise we have to do. We are having now 2 groups, one is core group and one is non-core group. Core group contains rho, g, v and non-core group contains f and a. Now do this thing, rho to the power a into g to the power b into v to the c into f is equals to some non-dimensional number, that is m0, l0, t0. So ultimately by doing the dimensional analysis on both the sides LHS and RHS, I will get the value of a, b, c. So those are found. G square means b comes out 2 and a comes out your minus 1 and c comes out minus 6. So ultimately over the left hand side the formula becomes g square f upon v to the power 6 into rho, because since see the LHS is equated to a non-dimensional number, so therefore ABC will come out so that the LHS becomes a non-dimensional number. So in case the value of A is minus 1 and value of B is 2 and value of C is minus 6, then the left hand side becomes a non-dimensional number. We have done this exercise with one non-core group member. Now do the same exercise with the other non-core group member, that is A. So therefore do the same thing with A. So you will get one more non-dimensional number, that is g square a upon v to the 4. So how we found? Simple, that is our simple dimensional analysis method, means simple rho to the power a equals b and v to the c into f equals to m to the power 0, l to the 0, t to the 0. So in case we are equating both the sides, and again over the left hand side for same basis the indices are added. Now indices are compared on both the sides, we get 3 equations with 3 unknown variables. So ultimately a equals to 1, b equals to 2 and c equals to 6. So like this we have done the exercise to find out the value of ABC. So similar case is there, that in case we are using other non-core group member, that is A, the same dimensional analysis methodology, ultimately we get the value of ABC and another non-dimensional number is g square a upon v to the 4. Now why we have done this exercise? Can you imagine that why we have done this exercise? Simple. Remember one thing, that in case there is a non-dimensional number, then it is a pure number. In case we square it or cube it or multiply with any number or add with any number, it remains non-dimensional. A non-dimensional number, whatever exercise is done with a non-dimensional number, whatever mathematical operation is done with a non-dimensional number, then it remains non-dimensional. Now this beauty of non-dimensional number can be used for making empirical relations. Now again go to the same case, that is in place of m keep the non-dimensional number, that is earlier what I was choosing the multiplication f, rho and a, so therefore that I was choosing as m. But now in place of m keep the non-dimensional number, the first non-dimensional number which we got, that is g square f upon v to the power 6 into rho, and in place of n we were taking previously we were taking v into g, now keep g square a upon v to the power 4. Now m and n over here both are non-dimensional. Now In case I do the same experiment over the kite, then for particular m I will get corresponding ends. So for particular m's there are corresponding ends. So in case I keep all those points in the coordinate system, that is m and n coordinate system, then I will get a curve. So in case m comes out to be 4.2 and we are 1 by 4 plus 2.3. Now the problem is solved since m and n both are non-dimensional. So therefore whatever mathematical formula is coming out empirically, it would be correct, because since for non-dimensional numbers the square is also, the cube is also, the 1 by 4 power is also, and half power is whatever the power is there over any non-dimensional number, and whatever number is multiplied with any non-dimensional number, it will remain a non-dimensional number. So over left hand side there is a non-dimensional number, and over the right hand side also there is a non-dimensional number. So this formula is correct in terms of magnitude as well as in terms of dimensional homogeneity principles. So this is what the beauty of non-dimensional number. So the method in which out of the total number of variables we pick up some variables to form the core group, then ultimately derive these non-dimensional number, this entire method is what called as Buckingham Pi theorem or Buckingham Pi method. Now let's take one more problem in which by the help of Buckingham Pi theorem it's found some non-dimensional numbers associated with a problem of natural convection. So go through these slides and watch them out, and ultimately you will get a better understanding for Buckingham Pi theorem.